So this is solving radical equations. So now we have an equation, has an equal sign there, and inside of it we have a square root or a cube root, some kind of root, and we've got to solve for x. So that's going to involve at some point getting rid of the root. So we need, the first step is to get everything that is taken to the root, or under the root itself, whatever, by itself. So what we need to do is get rid of this number in front. Okay, so it's 2 times the square root, so I'm going to divide both sides by 2. And that gives me the square root of x plus 1 equals 2. And here's where we're going to get rid of the square root. So, because the square root on this right side is all by itself, so that's the next step, is to get rid of the root. We're trying to work our way to that x. So I need to get rid of that square root, so I am going to square both sides. Squaring a radical as its inverse, cancels it out, leaves me with x plus 1 on the left side. 2 squared is 4 on the right side. And then we're going to have, we have this x plus 1. We need that x by itself, so we minus 1. And we end up with x equals 3. Now, this does say check your solutions, and it says that for a good reason, because sometimes when we square both sides, you sometimes get this thing called an extraneous solution or an extra solution that doesn't actually work when you plug it back in. So you just plug it into your original equation. So I have 2 square root of, and now x we're going to say is 3. And I want to see, do I get the 4 that it should equal? So I have 2 square root of 4, which is 2 times 2, and that is 4, and that worked out, okay? So it checks out. This is my solution. So let's come over here to B, and here's the root. I need to get it by itself before I can get rid of it. So I have to get rid of this minus 1. So we're going to add 1 to both sides. So that gives me the cube root of 2x minus 9. Now it equals 3. Okay, so the root's by itself, so let's get rid of it by taking both sides to the power of whatever that root is. So that was a cube root, so I need to take it to a cubed power, or power of 3. So that way it cancels the root. Whoa, excuse me. And you end up with 2x minus 9 now equals 27. And now it's a matter of solving for x. So this is just linear, so we're going to add the 9. And we get 2x equals 36. Divide both sides by 2. And we get that x is going to be 18. Well, let's see if that actually works. So if I plug, I don't know why it keeps doing that. So if I plug it into the original, I have the cube root of 2 times 18 minus 9. Outside of the root, I have a minus 1. And I need this to equal this 2 right here. Okay, so I have cube root of 36 minus 9. Then I have the minus 1. So I have the cube root of 27 minus 1. 3 minus 1 equals 2. And that does match that. So that checked out. This is my solution. Okay. So now let's come down here to C. Okay. Now this one, it still has just one radical. It needs to be by itself, and it is. It's over here all by itself. On the right side of the equation, the left side of the equation has everything else. So I can go ahead and just get rid of the root. Now this is a square root, so I'm going to square both sides. I don't know why I was writing it there. Oops. So it's squared. So the right side, the square root and the square cancel. On the left side, I have to square all of that x plus 1. Now, that doesn't mean square x and square 1. That means I'm taking x plus 1 times x plus 1. Okay, so if you need to do the box method to distribute, where you take x and a plus 1 times x plus 1, you can do that. But you're going to get x squared plus 2x plus 1, and that equals 7x plus 15. All right. Well, now I have an x squared. So I see I have a quadratic. So I'm going to get everything to one side and hope I can just factor this. So we're going to subtract the 7x, and I'm going to subtract the 15. So I end up with x squared minus 5x minus 14 now equals 0. And this does factor. X minus 7 times an x plus 2. That is negative 7 times 2 is negative 14. Negative 7 plus 2 is negative 5. So when I set each of those equal to 0, remember you set x minus 7 equal to 0, set x plus 2 equal to 0. We end up with x is 7 and x is a negative 2. Now we have to check both of these answers because this is really when those extraneous solutions come out, is when you had an x squared as a result from squaring both sides. So let's plug in 7. Now we got to do it to both sides. So I'm going to go ahead and erase like around here so you can see what I'm doing here. So I'm going to plug in 7. So where I have x, I'm putting in that number. So I'll get 7 plus 1. I'm just kind of doing this underneath here. 7 plus 1 will be 8. Okay, and then I'm going to have square root of 7 times 7 is 49 plus 15. So I get 8 equals square root of 64, which 8 equals 8, and that is true. So I do know that that is a solution. Now let's check the negative 2. Okay, negative 2 plus 1 is negative 1 equals the square root of 7 times negative 2 is negative 14 plus 15. Now I can already tell this isn't going to work because of that negative, but just keep going. Negative 1 does not equal positive 1. So this cannot be a solution. It is an extraneous solution. So our only answer is x equals 7. All right, letter D has 2 radicals, okay? So the one on the right is all by itself. So I'm ready to square it to get rid of the radical. And yes, I know the other side isn't all by itself, but it all comes out. So if I square both sides, excuse me, the right side just becomes 3 minus x. But this left side is still 2 terms being squared. So it's square root of x plus 2. That's going to be one term. And then plus 1 is going to be another term. So I'm going to do it down here. I'm going to do the box. The square root being one term. The plus 1 being the other. Okay, square root of x plus 2 times square root of x plus 2 is just x plus 2. The square roots would cancel because it makes that being squared. 1 times square root of x plus 2 is square root of x plus 2. And 1 times 1 is 1. Okay, now in here I have some like terms. Okay, so I have a constant and I have a constant. I do have this x squared, or x. It's not, it doesn't have a like term, but the square roots would be considered like terms too. I'm guessing 3 there. So when I write this side out, I have an, I have an x. I have a 2 and a 1, so that's going to be plus 3. And when I add these radicals, I end up with 2 of them, so 2 square root of x plus 2. Now that right side, the radical and the power cancel, so I end up with 3 minus x. So again, I'm left with a radical. So I'm going to have to do the squaring both sides a second time, but I have to get it by itself first, okay? So this does have some extra steps that are a little different than before, but still doable. You just have to do it twice. So I'm going to subtract x. I'm going to subtract the 3. And when I do that, I'm left with 2 square root of x plus 2 equals, well, those 3's cancel, so it leaves me with a negative 2x. I still don't have the radical by itself, so I have to divide it by that 2, so those 2's can cancel, and I'm left with square root of x plus 2 equals negative x. Radical is now by itself, so let's square it to get rid of it. So I have an x plus 2 equals x squared. Okay, so now I have a quadratic. So we want to solve it. So I'm going to move everything to the other side. I'm going to subtract the x and subtract the 2. And that way I can factor it. So I get 0 equals x squared minus x minus 2. And that does factor. Gives me an x minus 2 times an x minus 1. Plus 1, sorry. Whoop. Negative 2 times a positive 1 is negative 2. And negative 2 plus 1 is negative 1. So it's that middle term. So I have an x minus 2 equals 0. And an x plus 1 equals 0. So that gives me a positive 2 and a negative 1. And we have to check these. All right, so I'm going to check the positive 2 first. So let me kind of erase this stuff around here. If I plug in a positive 2 here, I get the square root of 2 plus 2, which is 4. So I get square root of 4 plus a 1 equals the square root of 3 minus 2, which is 1. Okay, so I'm going to end up with 2 plus 1 equals 1. Well, 3 does not equal 1. That doesn't make any sense. So that can't be an answer. So let's try the negative 1. All right, so if I plug in, let's separate those out here. If I plug in negative 1 into this first x in the root, I get a negative 1 plus 2, so I get square root of 1 plus 1 equals, and then I have 3 minus a negative 1 makes 3 plus 1, so I have a square root of 4. Well, that's 1 plus 1 is 2. Square root of 4 is 2. This checks out. So our only answer here is x minus 1.